Welcome to a review of factoring. This is Mrs. O'Brien, and I'm just going to kind of guide you through this review so that you're best prepared for class tomorrow. Now let me just kind of make a note with you. The best way to be successful with the video is to interact with it, meaning I want each of you, after I assign a problem, to try the problem on your own. Turn off the video, give it a shot, and then put the video back on and see if your answer is correct. Now, in terms of review of factoring, in the past you've learned GCF, or greatest common factor, difference of two perfect squares, what I call basic trinomial, which you'll recognize when you see it, and of course regrouping. With that said, we're going to go to our first example, which will be example 1. And it's to factor 10 ab cubed minus 15 a squared b squared. Again, turn off the video, try it, and then turn it back on to check. Welcome back. Hopefully you recognize this as a GCF, or greatest common factor method. The 10 and 15 have a GCF of 5. Both the first term and the second term have a common factor of a, but the greatest number of a's they have in common is 1. So we're going to factor out an a. Both the first and second term have a common factor of b, but the most b's that they both have are 2. So our GCF is 5ab squared. I'm going to draw my parentheses, and my key is to figure out what I multiply 5ab squared by to get my original problem. And 5 times 2 will give us 10. A times 1 will leave us a, and b squared times b will give us b cubed. Now, in order to get a negative 15, we're going to have to multiply 5 times negative 3. To get an a squared, we're going to have to multiply a times a, and we already have a b squared. So again, you can just do a quick distributive property to check that you have the correct answer. Our second example is to factor 4a squared minus d squared. Again, please turn off the video and give it a shot. Hopefully you recognize this as a difference of two perfect squares. 4a squared can be thought of as 2a times 2a. Z squared, because it's positive, times a negative will give us a negative z squared, and it'll be plus z minus 3. The beautiful part about this is that when you have the difference of two perfect squares, the oi, like outer inner, cancel out. For example, our inner here is 2az, and our outers are negative 2az, and they will cancel. Okay, on to example 3, speeding right along. Everyone, I would like you to factor x squared plus 2x minus 15. Hopefully you recognize this as, quote, the basic trinomial method. In order to get an x squared, we need to multiply x times x. Now our last term has to multiply to negative 15. But the key is we want the two last terms to multiply to negative 15, but add up to positive 2, which gives us a plus 5 times a minus 3. Again, 5 and negative 3 multiply to negative 15, but we'll have the added benefits of the inners, which are 5x, and the outers, which are negative 3x, or as I call the oi's, combining and giving us a 2x. Example 4, we're going to look at a new problem, which is going to ask you to factor 15x squared minus 16x plus 4. Good luck. Okay, welcome back. Right now, you should recognize this as one that's going to need regrouping. it looks a little bit like our basic method because we have an x squared followed by an x followed by a constant. The issue here is that there's a 15 in front of the x squared. So what I'm going to do is multiply the 15 times 4 and say that's 60. And I want to think, what are the factors of 60 that will somehow add up to the negative 16? And in my mind, I'm thinking 10 and 6. So when I do this as a regrouping method, I'm going to think of it as 15x squared, and I'm now going to do minus 10x minus 6x plus 4. The minus 10x and the minus 6x will give us this negative 16x. And if I do that, I have an equivalent polynomial here, and I can factor out of the first two terms a 5x, and then I would do 5x times 3x will give us our 15x squared, and 5x times minus 2 will give us our negative 10x. On this side, I can factor out a negative 2. And if I do that, I'm going to get 2 times 3x gives us the negative 6x, and 2, or negative 2 times negative 2 gives us positive 4. Great right now, because we can see a common factor of 3x minus 2 in both terms. And so we're going to factor out that 3x minus 2, and we're going to multiply it by the 5x minus 2. And I put this in the other parentheses, this more squared one. You really don't need to, but I just wanted to stress that the 3x minus 2 times this first term gives us that. And the 3x minus 2 times the second term gives me this second term up here. Pretty awesome. Okay, we are now ready for our last official example. So here goes. We're going to factor 3x to the 6th minus 48x squared. See you in a moment. Welcome back. Here goes. We're going to start off with the GCF. The 3 and the 48 have a GCF of 3. The x squared and the x to the 6th have a GCF of x squared. 3x squared times x to the 4th gives us 3x to the 6th. 3x squared times 16 will give us 48x squared. Again, you can double check that. Oh my, bells are going off. We have a difference of two perfect squares. We're going to make the 3x to the 4th minus 16, x squared minus 4 times x squared plus 4. And then we're going to go a step further, and we're going to factor x squared minus 4 into x minus 2 times x plus 2, leaving the last term as x squared plus 4. So with that said, I hope that this helped and that you'll be ready for class tomorrow when we do some more factoring. Have a good one.